Hi, this is Anthony, and in this demonstration video, I'm going to show how you can use Graderworks to analyze part files in a folder. Also, I'm going to show how you can set up the geometric similarity checking algorithm. And finally, I'm going to show how you can use Excel, how you can set up formulas in Excel to compute an actual grade for students. So, getting started, um, I have some files, some SOLIDWORKS part files in this folder. And these weren't actually generated by students, but they represent a good example of types of things that students submit. So I have these part files, and I have an underscore, two underscores in each file name, and that represents like the username of the particular student, so we can easily identify who submitted which part. And this is really common for SOLIDWORKS classes, or using a course management system where you can like download files, or you can just ask your students to name the files in a particular way. Okay, so we have these files. I have 12 files right here, and I want to grade them um, to see if they're correct or not. So I asked some people to draw this part right here. It's a pretty simple part um, within SOLIDWORKS. It's a little bit tricky because right here these two edges do not actually line up, and so sometimes there's a common mistake where uh, people don't have it. They do have it lining up, and where technically it's not supposed to. Okay, so I had some people draw this, and now we want to grade them. So let's go ahead and open up Graderworks. I'm going to go to my desktop and run the Graderworks application. First, I have to tell it where the files are located by specifying the root folder. So they're in this folder, so I'm just going to copy this path, paste it here. Next, I'm going to click on Configure and change some of the settings. So the first is how will it identify the username of the student. And I've set it so that the start identifier will be the underscore, and then the end identifier will also be an underscore. And everything in between those will be the username. For the type of assignment, I'm going to say I have SOLIDWORKS files. I could instead say like I have zip folders that were submitted by students or something else. For the type of SOLIDWORKS file to analyze, I only have part files, so I'm just going to uncheck the drawings and assemblies. For units, I want to use the MKS unit system, which is the default, the system units. That way it'll be consistent across all the different students. Next, I'm going to go to the comparison tab, and I want to run the geometric similarity comparison so that I can assign partial credit for this assignment. So I'm going to click compare part to references specified below. And I could insert more than one reference if I wanted. I'm just going to do one. So I'm going to use this file right here, which I drew. And I'm going to just copy the path and do Control V to paste it into this box within Graderworks. Okay, I'm going to click OK. Next, I'm going to tell it to start. Then it's going to pre-analyze my correct answer file, the A10 APG part.solidworks part. And then it's going to go through and open each part within SOLIDWORKS in the background, extract properties, run the geometric similarity comparison test, and then output all the results to this output.csv file. So you can see it's finished, and then over here in my folder I have the analysis.csv file and also an output.csv file. Let's open this output.csv file. And you can see the headings here. We have first the extracted username, next is the file path, next we have just the file name, the type of document. In this case it's only SOLIDWORKS parts, but it could have been drawings and assemblies as well. And the mass in kilograms, because this is MKS units, volume, density, surface area, center of mass in the X, Y, and Z. And I have the last saved by username. Next I have the creation date. Then I have the last save date. And finally I have the comparison score with respect to the correct answer file. And also right here I have an estimated error of the comparison analysis. And this is helpful because it tells me like what range of values are going to be okay for the comparison score. Okay, so now I'm going to set up some Excel formulas to grade these files. And I've automated the system by creating some macros that I'm going to run. So I'm going to go to View, Macros. The first macro I'm going to run is this prepare for grading. So I'm going to run it. And what it did is it renamed this first sheet and it gave it the name data. You can see down here. Next, it made a new sheet called metadata, which we will input some information that we want to use for grading. So what it's going to do is it's going to grade, in a minute, it's going to grade the mass and check the density and also check the similarity score to see if the student got it right. And we want to specify a range of acceptable values for the mass. So I'm going to say the mass has to be within 1% of the correct answer. So the correct answer was this value. So let me copy this. I'm going to paste it into the correct answer. So the mass must be within 1% of this value. Next, for the correct density tells me that the student assigned the material correctly within SOLIDWORKS. So the correct density is 2700. Type that in. Then I'm going to say if the density is wrong, I want to take 10 points off. If the mass is not correct, I'm going to automatically take 5 points off. Okay, now that I have that set up, I can run my second macros. I'm going to go to View Macros and run the grade assignment macro. I click Run, and it's finished. It set up a few more columns over here, a mass check, similarity, 100% correct check, a density check, automatic points taken off, and a final grade. So in this example, you can see that this first file, which was actually the correct file as well, the correct answer file as well, it's obviously going to receive a grade of 100% because it's 100% correct. Also, there are several other files that will receive 100. This student right here, he did not assign the correct material, and I can tell because the density is not right. Also, his mass is very much is way off, but that's probably because of the incorrect density. And his similarity score is also relatively low, so it's about 76%. So then I just took this score and I said, yeah, automatically got 5 points taken off for the wrong mass, automatically 5 points taken off for the wrong density. So this is how this will be his final score would be. So it'd be 76 minus 15. And that's what is going on all these columns. So next we want to check to see like what does the part actually look like. So I'm going to open up SOLIDWORKS and actually look at the part files, and we can see if the grade seems fair based on how well the student actually did. So this is the correct answer. And then we want to compare it. Let's compare it to this part. Okay, we can see that the material is not specified. Also, if we go through and start looking at this file, I can see that this was not a fully defined sketch. I can actually just drag this out. This is probably the reason why the similarity score was relatively low, because the student just kind of guessed on this value, didn't actually specify it, and so it's probably wrong, which is the reason for the low score. Besides that, it looks about correct. You'll also notice that this lip is missing, that these parts actually line up as well. So without going in and like looking through every feature, I'm not 100% sure what the student did wrong, but those are at least two things I can easily find that show the student didn't do it correctly. And based on how close it is to the correct file though, we would assign him a score of 61, at least in this example. So you can tweak the algorithm, the grading algorithm, to use the score, comparison score, and also how many points you're going to take off for maybe the wrong material, or you can invent your own grading algorithms. And this is just an example. So thanks for watching, and watch some of the other videos that I've also posted. Thank you.